GX systems, and it's a total waste in order to change it every single year. Every single major computer company, from Foxconn to Quanta to Wistron, the list
And
goes
we
on
are
and on,
back.
to HP and Dell and Lenovo. Everybody knows how to build these systems, and so the fact that we can squeeze Rubin, Vera Rubin into
Yeah.
even though the
Listo.
performance is so much higher, but very importantly, the power is twice as high.
Venga, venga, come on down, sobrino. Claro que sí. Wow.
And yet, and this is the miracle, the air that goes into it, the air flow is about the same. And very
He was noise. Okay, absolutely.
with 45 degrees C, no water chillers are necessary for data centers. We're basically cooling this supercomputer or hot water. It is so incredibly efficient. And so this is the new rack. 1.7 times more transistors, but 5 times more peak inputs per one. 300 times more peak of training. They're connected on top using Spectrum X.
These are the seats.
This is the world's first manufacturing chip using TSMC's new process that we call It's a silicon photonics, integrated silicon photonics process technology. And this allows us to take silicon photonics directly right to the chip. And this is 112 ports.
Teaching an engineering class, so these are the new NVIDIA systems. I put their finals to this, they want to get like sponsorships, like endorsement. They want to work for one of these Fortune 500 companies. I'm not like, the better my students do, I can send those letters of recommendation. You know what I mean? Even though I'm old. I'm 44 this year. Years I have grandkids, you know what I'm saying? Changing the dynamic of everything. Welcome to the shop. I'm really happy to you, sir.
Using them 4 on the side and flipper cut stuff.
And can we do like a light to lead trim on the top? And if you want to trim some more, we can. Would that be okay?
That'll be fine.
Okay, and then we're going to tuck away this whirlpool with the scissors and perform it around the corner. The back, outline everything on your square cut. Would you like for us to trim your eyebrows today? No. I have pointed to it, but you know I'm going to have the music full blast. If you need me, raise your hand. I can hear you for very low, right? I'm going to travel to the future. I'll be right back. Welcome to the South. Go ahead.
Spectrum X, that just took off. And I made us the largest network company in the world, as I mentioned. This next generation Spectrum X is going to carry on that tradition. But just as I said earlier, AI has reinvented the computing stack. Every layer of the computing stack. It stands to reason that when AI starts to get deployed in the world's enterprises, it's going to also reinvent the way storage is done. Well, AI doesn't use SQL. AI uses semantics information. And when AI is being used, it creates this temporary memory plus key cache, key value combination.
I rotate you this promote, okay?
We need to succeed. No matter if you're black or white, the father's side. No matter if Let's all make some joyful sound. Love, love, love is what we need. Love, love in order to see. Love. This season is mixed by Marvin.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Hello, Las Vegas! Happy New Year! Welcome to CES. Well, we have about 15 keynote worth of material to pack in here. I'm so happy to see all of you. You got 3,000 people in this auditorium. There's 2,000 people in the courtyard watching us. There's another 1,000 people apparently in the fourth floor where there's supposed to be NVIDIA show floors, all watching this keynote. And of course, millions around the world are going to be watching this to kick off this new year. Well, every 10 to 15 years, the computer industry resets. A new platform shift happens. From mainframe to PC, PC to internet, internet to cloud, cloud to mobile. Each time, the world of applications target a new platform. That's why it's called a platform shift. You write new applications for new computers. Except this time, there are two simultaneous platform shifts, in fact, happening at the same time. While we now move to AI, applications are now going to be built on top of AI. At first, people thought AIs are applications. In fact, AIs are applications. But you're going to build applications on top of AIs. But in addition to that, how you run the software, how you develop the software fundamentally change. The entire five-layer stack of the computer industry is being reinvented. You no longer program the software you train the software. You don't run it on CPUs, you run it on GPUs. And whereas applications were pre-recorded, pre-compiled, and run on your device, now applications understand the context and generate every single pixel, every single token completely from scratch every single time. Computing has been fundamentally reshaped as a result of accelerated computing, as a result of artificial intelligence. Every single layer of that five-layer cake is now being reinvented. Well, what that means is some $10 trillion or so of the last decade of computing is now being modernized to this new way of doing computing. What that means is hundreds of billions of dollars, a couple of $100 billion of VC funding each year is going into modernizing and inventing this new way. And what it means is $100 trillion of industry, several percent of which is R&D budget, is shifting over to artificial intelligence. People ask, where's the money coming from? That's where the money's coming from. The modernization of AI to AI, the shifting of R&D budgets from classical methods to now artificial intelligence methods. Enormous amounts of investments coming into this industry, which explains why we're so busy. And this last year was no different. This last year was incredible. This last year, there was slide. This is what happens when you go back. 2025 was an incredible year. It seemed like everything was happening all at the same time, and in fact, it probably was. The first thing, of course, is scaling law. In 2015, the first language model that I thought was really going to make a difference, made a huge difference at first. 2017, Transformers came. It wasn't until 5 years later, 2022, that ChatGPT moment happened, and it awakened the world to the possibilities of artificial intelligence. Something very important happened a year after that. The first O1 model for ChatGPT, the first reasoning model, completely revolutionary. Invented this idea called test-time scaling, which is a very commonsensical thing. Not only do we pre-train a model to learn, we post-train it with reinforcement learning so that we can learn skills. And now we also have test-time scaling, which is another way of saying thinking. We think in real time. Each one of these phases of artificial intelligence requires an enormous amount of computing. And the computing law continues to scale. Large language models continue to get better. Meanwhile, another breakthrough happened. And this breakthrough happened in 2024. Agentic systems started to emerge. In 2025, it started to proliferate just about everywhere. Agentic models that have the ability to reason, look up information, do research, use tools, plan futures, simulate outcomes. All of a sudden, it started to solve very, very important problems. One of my favorite agentic models is called Cursor, which revolutionized the way we do software programming and video. Agentic systems are going to really take off from here. Of course, there are other types of AI. We know that large language models isn't the only type of information. Wherever the universe has information, wherever the universe has structure, we could teach a large language model, a form of language model, to go understand that information, to understand its representation, and to turn that into an AI. One of the biggest, most important ones is physical AI. AI that understand the laws of nature. And then, of course, physical AI is about AI interacting with the world, but the world itself has information, encoded information, and that's called AI physics. AI that, in the case of physical AI, you have AI that interacts with the physical world, and you have AI physics, AI that understands the laws of physics. And then lastly, one of the most important things that happened last year, the advancement of open models. We can now know that AI is going to proliferate everywhere when open source, when open innovation, when innovation across every single company and every industry around the world is activated at the same time. Open models really took off last year. In fact, Last year, we saw the advance of DC-1, the first open model that's a reasoning system. It caught the world by surprise, and it activated literally this entire book. Really exciting. We're so happy with it. Now we have open systems all over the world, all different kinds. And we now know that open models have also reached the frontier. Still solidly 6 months behind the frontier models, but every single 6 months, a new model is emerging, and these models are getting smarter and smarter. Because of that, you can see the number of downloads has exploded. The number of downloads is growing so fast because startups want to participate in the AI revolution. Large companies want to, researchers want to, students want to, just about every single country wants to. How is it possible that intelligence, the digital form of intelligence, will lead anyone? And so open model has really revolutionized artificial intelligence last year. This entire industry is going to be sure as a result of it. Now, we heard this inkling some time ago. You might have heard that several years ago, we just started to build and operate our own AI supercomputer, GX Cloud. A lot of people ask, are you going into the cloud business? And the answer is no. We're building these GX supercomputers for our own use. Well, it turns out we have billions of dollars of supercomputers in operation so that we can develop our open models. I am so pleased to get that we're and it's starting to attract attention all over the world and industries because we are doing frontier AI model work in so many different domains. So what that we did in proteins, in visual biology, opportunity to be able to synthesize and generate proteins, open quality to understand the structure of proteins. Evo 2, help understand and generate multiple cases, otherwise beginnings of cellular replication. O2, AI that understands laws of physics. The work that we do with forecasting, the work that we do with coordinates, really revolutionize the way people are doing weather prediction. We've now run groundbreaking work with the first hybrid transformer SSM model that's incredibly fast and therefore can think for a very long time, or can think very quickly with that for now a very long time, and produce very, very smart intelligent answers. Neutron 3 is groundbreaking work. You can expect us to deliver other versions of Neutron 3 in the near future. Cosmos, a frontier, open, world foundation, one that understands how the world works. Brute, a humanoid robotic system, articulation, mobility, locomotion. These models, these technologies are now being integrated, and each one of these cases open to the world. Frontier humanoid robotics models open to the world. And then today, we're going to talk a little bit about alpha models, the work that we've been doing in self-driving cars. Not only do we open source the models, we also open source the data that we use to train those models. Because in that way, only in that way, can you truly trust how the models came to be. We open source all the models, we help you make rigorous ranking. We have a whole suite of libraries. We call them NEMO libraries, physics NEMO libraries, and the Clara NEMO libraries, each bio NEMO libraries. Each one of these libraries are life-cycle management systems of AI, so that you can process the data, you can generate data, train the model, you can create the model, evaluate the model, guard the model, all the way to deploy the model. Each one of these libraries are incredibly complex and all over the different sources. And so now on top of this platform, NVIDIA is a frontier AI model builder. And we build it in a very special way. We build it completely in the open so that we can enable every company, every industry, every country to be part of this AI revolution. I'm incredibly proud of the work that we're doing. In fact, if you notice the chart shows that our contribution to this industry is bar none. So you're going to see us, in fact, continue to do that, if not accelerate. These models are also world-class. Not only are they open, they also top the leaderboards. This is an area where we're very proud. They top leaderboards in intelligence We have important models that understand multi-modality documents, otherwise known as PDFs. The most valuable content in the world are captured in PDFs. But it takes artificial intelligence to find out what's inside, interpret what's inside, and help you read it. And so our PDF retrievers, our PDF are world class. Our speech recognition models, absolutely world class. Our retrieval models, basically search, semantic search, AI search, the database engine of the modern AI era, world class. So we're on top of leaderboards constantly. This is an area we're really proud of. And all of that is in service of your ability to build AI agents. This is really a groundbreaking area of development. At first when people would check these came out, people said, gosh, it produced really interesting results, but it hallucinated greatly. And the reason why it hallucinated, of course, it can memorize everything in the past, but it can't memorize everything in the future and the current. And so it needs to be grounded in research. It has to do fundamental research before it answers the question. The ability to reason about, do I have to do research? Do I have to use tools? How do I break up a problem into steps? Each one of these steps is something that AI models knows how to do. And together, it's able to compose it into a sequence of steps.
Basic stuff, as you know, they will go into use contains alcohol.
This is the wonderful capability of reason. We can we've never seen before, and break it down into circumstances and knowledge that we know how to do because we've experienced it. And so the ability of AI models now to be able to reason is incredibly powerful. The reasoning capability of agents opens doors in all of these different applications. We no longer have to train an AI model to know everything on AI, just as we don't have to know everything on AI. We should be able to, in every circumstance, reason about how to solve that problem. Large language models have now made this fundamental leap. The ability to use reinforcement learning and chain of thought, full search and planning, all these different techniques. Reinforcement learning has made it possible for us to have this basic capability, and it's also now completely open source. But the thing that's really terrific is another breakthrough that happened. And the first time I saw it was with Ervin's Perplexity. Perplexity, a search company, the AI search company, really innovative company.
Brace yourself, we're going to be using this.
Using multiple
Very sharp, very
dangerous. I thought it was completely genius. Of course we would do that. Of course, an AI would also call upon all of the world's great AIs to solve the problem it wants to solve at any part of the reasoning chain. And this is the reason why AIs are really multi-modal, meaning they understand speech and images and text, videos and 3D graphics and proteins. It's multimodal. It's also multi-model, meaning that they should be able to use any model that best fits the task. And it's multi-cloud by definition, therefore, because these AI models are sitting in all these different places. And it also is hybrid cloud. Because if you're an enterprise company or you built a robot or whatever that device is, sometimes it's at the edge, sometimes the radio cell tower, maybe sometimes it's in an enterprise, or maybe it's a place where a hospital where you need to have the data in real time right next to you. Whatever those applications are, we know now this is what an AI application looks like in the future. Or another way to think about that, because future applications are built on AIs, this is the basic framework of future applications. This basic framework, this basic structure of agentic AIs that can do the things that I'm talking about, that is multi-model, is now turbocharged AI startups of all kinds. And now you could also, because of all of the open models and all the tools that we provided you, you can also customize your AIs to teach your AI skills that nobody else is teaching. Nobody else is causing their AI to become intelligent or smart in that way. You could do it for yourself. And that's the work that we do with Neutron, Nemo, and all of the things that we do with open models is intended to do. You put a smart router in front of it, and that router is essentially a manager that decides which one of the tasks based on the intention of the prompts that you give it which one of the models is the best fit for that application, for that solving that problem. Okay, so now when you think about this architecture, what do you have? When you think about this architecture, all of a sudden you have an AI that's on the one hand completely customizable by you, something that you could teach to do your own very skills for your company, something that's domain secret, something where you have deep domain expertise. Maybe you've got all of the data that you need to train that AI model. On the other hand, your AI is always at the frontier by definition. You're always at the frontier on the one hand, you're always customized on the other hand, and it should just run. And so we thought we'd make the simplest examples to make it available to you. This entire framework, we call them blueprints. And we have blueprints that are integrated into enterprise SaaS platforms all over the world, and we're really pleased with the progress. But what we do, we show you a short example of something that anybody can do.
Let's build a personal assistant. I wanted to help me with my calendar, emails, to-do lists, and even keep an eye on my home. I use Breath to turn my DGX Spark into a personal cloud. So I can use the same interface whether I'm using a cloud GPU or a DGX Spark. I use a Frontier Model API to easily get started. I wanted to help me with my emails, so I created an email tool for my agent to call. I want my emails to stay private, so I've built a model that's running locally on the Spark. Now for any job, I want the agent to use the right model for the right task, so I'll use an intent-based model router. This way, prompts that need email will stay on my Spark, and everything else can call the Frontier model. I want my assistant to interact with my probe, so I'll hook it up to Hugging Face's Reachy Mini robot. My agent controls the head, ears, and camera of the Reachy with tooltips. I want to give Reachy a voice, and I really like Button Labs, so I'll hook up their API.
Hi, I'm Reachy, running on DGX Spark.
Hey Reachy, what's on my to-do list today?
Your to-do list today. Grab groceries, eggs, milk, butter, and send Jensen the new script.
Okay, let's send Jensen an update. Tell him I'll have it for him by the end of the day.
Will do.
Reachy, there's a sketch too. Can you turn it into an architectural rendering?
Sure.
Nice. Now make a video and show me around the room.
Here you go.
That's great. With Breath, I can share access to my Spark and Reachy, so I'm going to share it with Anna.
Hey Richie, what's Potato up to?
He's on the couch. I remember you don't like this. I'll tell him to get off. Potato, off the couch.
With all the progress in open source, it's incredible to see what you can build. I'd love to see what you create.
Isn't that incredible? Well, the amazing thing is, that is utterly trivial now. That is utterly trivial now. And yet, just a couple of years ago, all of that would have been impossible. Absolutely unimaginable. But this basic framework, this basic way of building applications, using language models that are pre-trained and they're proprietary, they're frontier, combine it with customized language models into a agentic framework, a reasoning framework.
Yep. This is so when you get rich and famous, you don't forget about us, okay?
And
Give
maybe
me 1 second, we're going to dust you off and take the battle
This is
on.
basically the architecture of AI.
Whatever you normally say is fine. Anything that you give us, I'm going to hide from my girlfriend, okay? If she sees it, it will disappear. Alright, you're all set to go. My eyes are starting to hear. You know, you guys always see me with my engineering glasses. I'm being able to adjust, you know, going from different lenses, you know. Thank you very much. You have a blessed day. We'll see you next time, and we'll salute you, okay? Thank you very much. Air Force, Space Force, always on duty. G.I. Joe forever, baby.
We have the benefit of working with some of the world's leading enterprise platform companies.
Okay, let's take a quick pause right here. We need to clean this up.
their entire AI and data processing platform is being integrated and accelerated by NVIDIA today. ServiceNow, the world's leading customer service and employee service platform. Snowflake, the world's top data platform in the cloud. Incredible work that
Very
is
nice.
being done there.
Great success.
CodeRapid. We're using CodeRapid all over NVIDIA.
And we'll be right back.
To detect, to find AI threats. NetApp, their data platform now has NVIDIA's semantic